Okay, so today we're going to talk about the Pythagorean identity. So in the try this, it says to draw the unit circle, put point P on the unit circle in quadrant 1, draw in the radius, and then label the point. All right, so let's draw our unit circle. Okay, so we're going to put point P on the unit circle. I'm going to draw in my radius. So hopefully you recall, since my unit circle is up, down, left, right, 1 unit, that means my radius is equal to 1. My point is labeled cosine theta, sine theta. Remember, cosine is x and sine is y. All right, so from this, remember, in order to come up with this point here, we dropped the altitude straight down and created this right triangle here. Okay, so let's recall that this value, cosine theta, is your x value. So it's how much you went over to the right from the origin. So cosine is how much you went over to the right from the origin. So if this value here is just cosine, then I know this length here is cosine theta. And if this value here, this sine value, my y value, is how much I'm going up from the x-axis, then I know this value here is whatever this value is here, over here, and that is sine theta. All right, so knowing that, I can come up with the Pythagorean identity. So now first let me tell you what an identity is before we get to the Pythagorean identity. So an identity is an equation that is true for all values of its variable. So no matter what value I plug in for the variable, it'll always be true. Okay, so using the unit circle, we are going to come up with the Pythagorean identity. So let's put that down, that the Pythagorean identity comes from the unit circle. So obviously, if it's the Pythagorean identity, it must have something to do with the Pythagorean theorem, which is a squared plus b squared is equal to c squared. Now, remember, c is your hypotenuse. So using your unit circle, which side is the hypotenuse? So remember, the hypotenuse is opposite your right angle. So your hypotenuse is 1. So that's 1 squared. Your A and your B are your legs. It's the other two sides. So it doesn't matter really which one goes where. So my A is going to be sine theta, and I have to square that. Your B, just going to move that over. Your B is going to be your cosine theta, and I have to square that. So that's the Pythagorean identity, and we would write it as sine squared theta plus cosine squared theta is equal to 1. So, and what this means is this, that no matter what value I plug in for theta, no matter which angle I could plug in 60 degrees, I could plug any of the values that we've talked about in class, 60, on 150, 330, 270. I could plug in 8 degrees. I could plug in 179 degrees. No matter what value I plug in for theta, and when I square them, I will always get 1. So this is something that you have to know. You have to memorize the Pythagorean identity. Okay, so now, from the Pythagorean identity, hold on. Okay, so from the Pythagorean identity, sine squared theta plus cosine squared theta equals 1, there are other identities that come from this. So we're going to talk about derivation number 1. So just rewrite the identity, sine squared theta plus cosine squared theta equals 1. And one of them comes from dividing everything by cosine theta, cosine squared theta. So divide by cosine squared theta. And this is what we get. So what is sine divided by cosine? So remember, sine divided by cosine is tangent. So when I have sine squared theta divided by cosine squared theta, that is tangent squared theta. Plus, anything divided by itself is equal to 1. 1 over cosine, remember that's the reciprocal, and that is secant squared theta. So that's another identity that you have to know. And now I always tell the students, do you really have to memorize this? Not really, because as long as you know the Pythagorean identity, you should always be able to come up with this identity here. And one other thing is this. Knowing that this is true, one other thing that I could say is this, that I could take my 1 here and minus 1 from both sides, and therefore I would get tan squared theta is equal to secant squared theta minus 1. That's another identity, okay? But these two identities, you don't have to actually memorize because you can always come up with these identities just from this identity. Okay, so now let's talk about derivation number 2. All right, so starting off with the Pythagorean identity, so that is sine squared theta plus cosine squared theta equals 1. So instead of dividing everything by cosine, what if I divide everything by sine squared theta? All right, so anything divided by itself is 1, so I have 1 plus. Remember, cosine divided by sine is cotangent, so I have cotangent squared theta. 1 over sine, that's the reciprocal of sine, so that's cosecant squared theta. So that's another identity that you have to know. But again, as long as you know the Pythagorean identity, you should always be able to come up with this identity. And of course, just like the other one, I could minus 1 from both sides, and this is another identity. Cotangent squared theta is equal to cosecant squared theta minus 1. So that's another identity that comes from this. So this goes to that, this can go to that. They all come from the Pythagorean identity, so you have to know that. Okay, so let's just do some applications with this. So flip it over. Okay, so it says, show sine squared theta plus cosine squared theta equals 1 for theta equals 60 degrees using exact values. So they're giving you theta at 60 degrees. So we have sine squared 60 plus cosine squared 60 is equal to 1. I want to show that that's actually true, okay, using exact values. So the first thing you want to do is you want to plug in sine 60. Sine 60 is 0.8660. And 0.8660 is the square root of 3 over 2. And then we have to square that because it says to square it. Plus, plug in cosine 60, which is 0.5. That's 1/2 squared equals 1. All right, so we are simplifying here. The square root of 3 over 2 squared is 3 over 4. Plus 1/2 squared is 1 over 4. So 3/4 plus 1/4 is 4/4 equals 1. So 1 equals 1. And that is true. So I'm showing that the identity actually works. All right, so let's take a look at question number 2. It says, show using exact values for theta equals 5 pi over 6. So this is radian measure. So I don't want to put my calculated radians because I hate radians. I always forget to put it back. So I like to change this over to degrees. So let's do that right now. Remember, pi is equal to 180 degrees. So it's 5 times 180. Divided by 6. So 5 times 180 divided by 6 is 150 degrees. So I want to show that tan squared theta plus 1 is equal to secant squared theta. All right, so I have tan squared 150 plus 1 equals secant squared 150. All right, so let's plug in tan 150. So tangent of 150 is 0.5773. negative of that, sorry. So that is going to be negative the square root of 3 over 3. And then I want to square that. Plus 1 equals, now I don't have a secant button on the calculator, so what I need to do is cosine theta. It's cosine 150. So plug in cosine 150 in your calculator. Right, you get negative 0.8660, which will be negative the square root of 3 over 2. So secant is reciprocal of that, so it's negative 2 over radical 3, and then I want to square that. Okay, so we have here negative the square root of 3 over 3 squared would be 3 over 9, plus 1 equals negative 2 over radical 3 squared is positive 4 over 3. So you can use your calculator for this, but this is 3 ninths plus 9 ninths equals 4 thirds. So 3 ninths plus 9 ninths is 3 ninths plus 9 ninths is 12 ninths equals 4 thirds. And 12 over 9 reduces to 4 thirds equals 4 thirds. And that checks. Okay, so that's it. And we'll practice more in class tomorrow. Have a good night.